My name is Trevor Miller. I'm the Chief Operator, Treatment Division Supervisor for Running Springs Water District. We have a 1 MGD MBR treatment plant. 2002 was the first retrofit, was a EK 300 plant. 2010 we went RWs, and in 2017 we went to the OV 960s. So this is the flow process through the wastewater treatment plant. And then here's the timeline we had. We struggled too with dewatering and coarse suspended solids and pore screening and clogged diffusers, and through all these things that we've struggled through, we wouldn't change any of it, right? So we're dedicated to the MBR process. So in 2016, we did the installation of the OV 960s. We retrofitted one basin, took out 16 EK 300s, installed 10 OV 480s stacked on top of each other, so we have 5 OMUs. And then this is some data, the energy reduction that we saw from installing the OV 960s versus the EK 300s.
So just to go back one slide. So throughout the history of Running Springs, there's been quite a few equipment upgrades. A lot of it has focused on the membrane equipment, but there was also some upgrades to the blowers. But just to give you a brief idea of what some of those equipments have done over the history of the plant is, just looking at the total air scour for the MBR plant, as you can see, going from the inception of the plant in 2002.
Yes.
All the way up to the current time, there's been a drastic reduction in the overall air scour. Now, even more important than just the air scour, we've also been able to increase the capacity of the plant quite significantly. So at the same time, that we've decreased the air scour, we've also been able to increase the capacity of the plant by 50%. And that's really due to the efficiency gains realized with the flat sheet technology. So we're able to squeeze more membrane area within the same footprint, and as a result, give Trevor a lot more treatment capacity. So I want to talk a little bit about what some of the key work we've been doing over the past 6 months there, which has to do with the installation of the OV 960 membranes. Back in Thanksgiving, I believe, is when we...
Yes.
Yeah.
The US
So
500.
it's a double stack system, gravity operation. When we first started the plant up, of course, usually the first week, things were running great. But then after a couple weeks, we noticed the performance really started to tail off. And, we started scratching our heads, well, why is that? Is there something going wrong? So in the spirit of data and gaining data to better understand what's going on, we did some benchmark testing. And all a benchmark test is run the plant under a certain set of conditions for a short period of time. And then when you have that benchmark data, you can use that later down the road as a reference point. So at any time, you can do a health check essentially on your system and compare it back to when you did the original benchmark. Well, our original benchmark data wasn't all that great because we saw that the permeability decline was quite significant. As you can see with the orange dots, the reversible fouling was pretty significant. So we did some more tests, figure out, okay, well, why is that? I mean, they're brand new membranes. Why is the permeability declining so much? And as it turns out, it was all due to the sludge quality. Obviously, the health of your sludge has a huge impact on the overall membrane performance and system performance. The reason for the decline in the sludge quality was once we got the new units installed, that allowed Trevor to do some maintenance on the other basin. We took the other basin offline, that shortened his SRT, less oxygen into the overall system, and then his bugs suffered, and the quality of the sludge declined. So as you can see, pretty rapid decline in permeability over just a few cycles. So once he got his repair work done to the existing or the other basin, his biology improved. It got back to its normal set of conditions. And as you can see from the permeability plots, the membranes recovered accordingly. So this, the beginning of the data is when the plant was first commissioned, or I should say, not the plant, but the new 960 double stacks. Obviously, we saw the rapid decline in permeability after startup. It sort of tanked a little bit, as you can see by the valley in the data. Once we got the healthy biology back, we got the sludge quality back, did a maintenance clean, the membranes responded and bounced back quite quickly.
Mike, how'd you get it back though? Trevor, how'd you get it back?
We brought the other reactor online and increased the SRT. Yeah.
Because with both basins online, your SRT is what, 40 days?
Yes.
And it dropped down to mid-20s.
Yeah, and more dissolved oxygen. One basin is we can swing it from MBR to a PA. So when we took that PA offline, that's when we saw the degradation in.
The oxygen and the SRT went down.
Yes.
Down
Right.
to the valley.
Right. So as you can see in this data, filterability was less than 10, so not great. Looking at performance after the second reactor was brought back online, you can see nice steady permeability. Looks like getting the sludge quality back really made the difference, and the membranes are performing quite well. Now that we have good sludge quality, we went back and redid our bench scale testing. As you can see, within each cycle there is some decline, but the membranes recovered much more significantly after each cycle compared to what the original benchmarking test did. Not a perfectly straight, flat line, but certainly a much better improvement over what we previously saw with the original benchmark test. Here's the actual data in our benchmarking. So what our benchmark test consists of is we run it for 6 cycles at 12 GFD. We look at the permeability at the start and end of each cycle, and then look at both the decline of permeability within each cycle, as well as the recovery after it goes into relax. So this gave us a really good idea or a good sense of how the overall system was performing, how the health of the membranes were, the level of fouling. So very, very useful tool that we'll be able to use throughout the life of the plant to really essentially go back and do a health check. So we started to get a little creative and look at the performance of the system, do some additional benchmark testing, but start looking at the impact of the air scour on permeability. So our previous operation had all been at 72 SCFM per 960. Saw really good permeability, stable permeability. Average was usually 20 to 25 GFT per PSI. So we decided to see, well, can we make that even better at a higher air scour just to see what the impact is. And as a result, we saw an even better benchmark test results. You can see not only the decline in permeability through each cycle, but also the recovery after each cycle gave us that little extra bump. So definitely good reference data to have. Then our next set of tests that we did is we looked at the other end of the spectrum, and that is how low of an air scour can we go. So we did the same benchmark test at 50 SCFM per 960 and to see what might the membranes be able to do. Now what's interesting with this data is the upper headers really didn't foul that much. Permeability was very stable, and as a matter of fact, the permeability actually increased over the benchmark test. However, the lower headers did see quite a significant drop in permeability over the benchmark test. And Trevor, I believe you did some inspections and found out what might have been happening there?
Yeah, we saw dewatered sludge in the basin, ragging, high coarse suspended solids. So the screening is a huge impact on the.
But did you see anything specific related to the lower air scour that might have caused the lower headers to have a greater decrease in permeability compared to the uppers?
I don't remember.
What is the CSS?
Coarse suspended solids, right? Like 1,500.
We like 200?
Yeah.
More or less.
So here are the numbers related to the actual benchmark test at 50 SCFM. As you can see, the upper headers saw really good recovery, but the lower headers definitely saw a greater decline in permeability with the lower air scour. So definitely some interesting results, promising results, and I think our next approach will probably be to bump the air scour up a little bit and really get a good sense of how low of an air scour we can go. Because during the summer, it really benefits you because that's your low flow season. So
Yes.
going lower and lower air scour certainly helps your
Yes.
plan out quite a bit,
Yes.
right? And then last but not least, just talk a little bit about some of the CIP optimization we've done with this plant. So we decided to do something a little different with Running Springs, and a lot of it had to do with the fact that Trevor was willing to implement this approach. But we wanted to see what the impact was with doing more frequent cleans, but at a much lower concentration, using a very dilute bleach solution to see if in fact that had any improvements on permeability. Would it make it more stable? Would we be able to sustain higher levels for longer periods of time? So the approach was to do about a 500 ppm maintenance clean every 2 weeks. And from the data, obviously, that we've seen so far, the results are really promising. So we suspect that we'll be able to perhaps extend it out to a dilute bleach maintenance clean every 3 weeks. So that tests are ongoing, but certainly as part of the overall optimization of the whole system. So some of the key takeaways from the tests that we've done or the work that we've done at Running Springs, obviously the sludge itself has a huge impact on your overall performance. You can't underestimate the importance of having high quality sludge. If you have bad sludge, you're just going to be banging your head up against the wall all the time. So understanding not only the quality or health of your sludge, but having a good understanding of what can impact it both negatively and positively. So that certainly is going to go a long way to a well-performing system, regardless of where your plant is. We've also learned that at Running Springs that the air scour itself does have a big impact on permeability, and it may give us a lot more tools to work with plants, because obviously not every plant operates at the exact same design flow rate 24/7. So having that flexibility will certainly give us some additional tools in our tool belt. And Running Springs is probably the first plant where we really started to implement this, but the benchmark testing is going to give us a great data set, allow us to essentially perform a health check on a system or a plant at any time. When you start up a plant, and by doing a benchmark test, you can sort of set a standard for the plant that you can refer back to at any time to really get a true understanding of the health of your plant, how well your plant is running, how well your membranes are running. You can use it as a way to gauge how well a CIP may have worked, if you implement new equipment, different air scour rates, all that type of stuff. But it really gives you a tremendous ability to really understand how your plant is running.
Thank you very much. Okay, well, before I interject with a bucket load of questions, is there anybody who would like to shout out? Yes, sir.
I'm interested in the depth of your basins.
Excuse me?
Total depth on your basin.
It is a 20-foot side water depth.
Yeah, his membrane, the diffusers, scour diffusers are about 18 feet deep.
Interesting. Any other queries? Sorry, yeah.
Can you explain filterability?
I got that.
Okay.
Okay. Filterability is a sample of the mixed liquor from your MBR, gravity through filter paper, folded into a cone, and it's basically how much filtrate you get over a 5-minute period. And it's filterability. We use it to gauge, I call it the canary in the coal mine, where how filterable your sludge is, kind of how healthy your sludge is.
Yeah, lots of useful things. Sometimes it's called TTF, which is time to filter. So you can either sort of do it your way and see how much you get within a certain time, or you have a certain volume and see how long it takes to filter that amount. So it's just yin and yang.
Well, we had to do that at Tenaya, where the filterability was so poor that instead of what do we get in 5 minutes, which was 0, we would say
Right.
we had to take it out even further.
Yeah, absolutely.
Taking 50 milliliters of mixed liquor and putting it in this filter paper. So what's good? How many milliliters are you expecting to get out of 5 minutes?
Our rule of thumb is anything greater than 10 milliliters over 5 minutes is acceptable. That once you hit that 10 and below 10, that there is some kind of an issue, and we need to start looking at start doing some filterability troubleshooting.
What is your frequency of running this test, process control test?
We do it daily.
Yeah, it's
Wait,
a pretty simple
filterability,
test,
or
though, right?
are you talking about the benchmark?
Filterability, we do filterability daily.
Yeah, daily.
Now, Trevor, tell us about some of the other tests that you run on your sludge as a way to keep track of it.
We do MLSS daily. We do coarse suspended solids daily. We do SCOD on the filtrate and SCOD on the permeate. We do that weekly. We'll do that if we see a problem, like if we see a decline in permeability, or if we make a change at the plant, we'll do a SCOD to see what that change did to the COD.
Yeah, Trevor likes to play cruel jokes on us. One of the things he does when he does his filterability test is he measures the turbidity of the filtrate that passes through the filter paper. But he likes to leave out the fact that it's the filterability turbidity, not the membrane turbidity.
Yeah.
So we'll get these super high turbidity numbers thinking, oh crap, what's happened?
Yes, sir.
You mentioned SCOD. What's your target on SCOD in test?
Well, based on the OVIVO guidelines, it's less than 50. And we can usually, we'll meet that when both basins are online and the SRT is where it should be. We'll be under 50 milligrams per liter in the SCOD in the filtrate. I'm sorry, what?
What do you normally experience?
Yes. 180. It's 180 in the filtrate, and it'll be 0 in the permeate.
Sorry, that's a soluble COD you're
Yes,
talking about.
soluble
The soluble
COD.
COD is going to depend on what goes in. I mean, for municipal, I guess that's about right. But if you're treating landfill leachate, you would sing from the heavens to get that kind of low COD.
Yeah.
So it just depends on the biodegradability. I was just going to ask something actually related to that, because you said you had to, the process prefers to work at a 40-day SRT than a 20-day SRT.
Yes.
Did I get that right? Mm-hmm. Because if you run at a 40-day SRT, your mixed liquor suspended solids would normally go up. Is that what you found, or
Yeah, we run it at 1%.
1%? Okay, right.
10 grams per liter, yeah.
10 grams per liter. And so at 40 days SRT, it's at 10 grams per
Yes.
liter. And do you know what the F to M ratio is at that particular?
Oh, it's
Because it must be getting quite... 0.2?
0.27, yeah.
Wow, that's remarkable. Okay. I need to go away and crunch the numbers, because that's the kind of guy I am. I have no life. Yes, Alana.
Two questions, actually. You guys kind of ignored the fact that the answer was 1,500 per liter for CSS.
Yes.
Is that now?
That's right now, yes. Yeah, so we're,
You're doing nothing about that?
well, yes, we are doing something about that.
Oh, look at me. Like, really?
That was for you. We're working on it, though.
Yes.
Are you still operating in a bio
No, our permit doesn't require it, so we're not right now.
Because you were the first bio-heat MBR plant in North America.
Yes.
I remember that back in 2002. Okay, so you are trying to reduce the CSS. Is that
Yes.
Oh, yeah. He doesn't enjoy getting down in his basin every quarter.
I mean, I think it's important for everybody to know that's outside of regulation, right? Everybody gets that? It's unbelievable that you're operating at that level.
Well, he tries to bring it back, but there's a massive front.
Yeah,
Yes.
yes.
Just chops it up and puts it back in. So he's already tried to recycle it down a lot of it.
Actually, I've got a sort of anecdote on that. There was a guy called Marcin Stefanski, who about 10 years ago, it must have been now, he went around all the plants in the UK and did this test whereby he essentially assessed, I guess you could call it the ragging propensity, like how readily stuff ragged, and in doing that, he also did the standard CSS measurement. About half the plants he tested had a macerator, which kind of forces all the stuff to go through into the bioreactor, and the other half didn't. You just sort of sieve it out and leave it. And the ones where you had a macerator, where you'd think, well, you shred it up nice and small, you put it through into the plant, it should be fine. You shredded it up, it should be fine. No. According to those tests, the plants, and these were sort of like full-scale operating plants, it wasn't like a bench-scale test or anything. The plants where there was a macerator that sort of like basically increased the load of coarse solids onto the bioreactor, that's where the ragging and clogging problems arose, it seems. So you kind of probably are up against it slightly if you've got a macerated solids going into the reactor. I don't know whether that would be standard practice now, whether you kind of go the other way and have a fine screen like the guys in the previous presentation had. You have a finer and finer screen, you tend to ameliorate these problems to a greater extent. I don't know why I'm telling you this. It's just going to depress you, isn't it, when I give you this stuff? But it is something which was found a while back in the UK. Are there any other queries? We've still got time for a few more questions.
I got one. Trevor, is the 40-day SRT, was that the original design, or is that something that you optimized to improve performance?
That was, based on the reactor volumes, that was the design SRT.
As high as like 53 days. It's a retrofit, right? So
Yeah.
the tanks are much bigger than they need to be. And before we ran 15,000 back in 2000. That was the initial.
Yep.
Okay, any other queries? Okay, I'm afraid I have more. So again, you were saying the F2M ratio is around about 0.23. The SRT has to be about 40 days per liter. 40 days in total in order to maintain that F2M ratio. So what is the feed concentration of BOD or COD particularly
About
strange? Or
190 to 210 milligrams per liter BOD. But the FTM is based on the, since we just started doing the CSS, we can pull that number out of the MLSS concentration and recalculate the F2M. So probably it's not 0.27.
right, because that
Right.
seems quite high for such a low load. I mean,
Yeah,
I don't
so
know whether my brain is gone. Very, very likely. I'm not as young as I was, but that seems quite a high number for such a low load. But any thoughts on that? No. Okay, it's just me then. Yes, sir. Okay. Yeah, okay, so it's the old engineering thing about being out by an order of magnitude. Perfectly normal, sir. Don't worry about it. Okay, so it's actually a very low F2M ratio, which means you might start to build up inerts as well as everything else. So, just to sort of add a little bit to the mix. Some Chinese plants actually have that particular issue where you run at very, very low F2M ratio because they just eat so healthy over there. So they don't have the same levels of organics going in. The inorganics to organics ratio is much higher. So you tend to get a buildup of inerts and get low F2M ratios. It's just another challenge, isn't it, Dennis? It really is. Any other queries before I start rambling on to no great effect? Okay. Oh, sorry. One more at the back, sir.
You mentioned that if filterability gets down to 10, that's typically where you start to see problems. If filterability is 11, is everything fine?
No,
It depends. It depends on the plant. Some plants run perfectly fine at close to 10 or maybe even a little under 10. Other plants, Trevor, if his filterability goes below the high teens, he calls me. But so no, it's not an absolute number.
And what's the, I'm sure you must have mentioned this, but what is the rating of the fine screen?
it's a 3 millimeter.
It's a 3 millimeter screen, okay, which, according to the previous presentation, that might be a little bit coarse now. And is it a two-dimensional, or is it a slot screen, or is it a...
No, it's a perforated plate.
It's perforated plate, so it's a
Yeah.
proper screen, as we would
Yeah.
say. Okay, that's great. Any other queries? See, the thing is, it is coffee coming up soon, so I think you might be let off. Okay, in that case, I'd just like to thank you guys in the usual way.